so let's go over this one, get our questions answered here. It is incredibly important, not necessarily for right this minute, but for what's in our future. It is very important that we know how to complete the square on an equation in two variables. So some of you have this down, some of you don't, and you need to pay attention now. Maybe come in, get a little extra practice at the board or something. We need to get this procedure just automatic for us. So we're going to complete the square. We got to get rid of this 1/2, and we got to get rid of this number. The order I do that doesn't matter, so I'll move the 6 over. Now I'm going to multiply everything by 2. What does multiplying by 2 do? It gets rid of the 1/2. You cannot complete the square. Some of you tried. You cannot complete the square if there's a coefficient on the x squared. It can't be done. Okay, so now I'm set up, ready to complete the square. So 1/2 of 8 is 4, and 4 squared is 16. So that's what's getting added to both sides. I'm going to add 16 to both sides. Some of you forgot to add that to both sides. That's easy to do. It's easy to forget. But you must add it to both sides. This side is a perfect square. That's why we call it completing the square. This side will be x minus 4. And this side is 2y plus 4 if I add those two things together. Now the square is complete, and it's just a matter of putting the equation back with y equals, getting y by itself again. So I'll move my 4 over. And divide everything by 2. Now, when I divide by 2, I divide the parentheses by 2, but nothing in it. Never ever divide anything in the parentheses by whatever. And then minus 2. So, now my equation's in what we call vertex form. So you can look at it and tell me the vertex is where? For -2. And my axis of symmetry then is x equals 4. Axes are like asymptotes. They're equations. Make sure that you write x equals 4. Francis?
You marked it wrong.
Okay, well, I'll take a look at it. I don't know. Okay. Now, the next problem was write the equation of the parabola knowing the vertex. Okay, now, gang, look at that equation. Doesn't that equation just tell me the vertex? So if I know the vertex is -1, 4, then I can at least do this much of my equation. Would you agree with me? Because that gives me a vertex of -1, 4. The only part of the equation that's missing is this guy, right? Which, you know, a multiplier out in front of the parentheses controls size. You know, how tall is he? How fast does he shoot up? So I need to figure out what that number is that's going to make sure the parabola goes through the point 2, 7. So this parabola has to contain that point, which means that x and that y have to work in this equation, right? Maria, I don't know what you got going on there, but it needs to be put away, okay? I'm sad that I haven't convinced you yet that there's nothing in this world more important than pre-cal. Except maybe your mother and God. Okay, now, the only thing I don't know is what this coefficient is right here, but I do know that x is 2 and y is 7. So here we go. 7 equals n times 2 plus 1 is 9. Well, 3 squared is 9. So I'm going to subtract the 4. side. So that coefficient is positive 1/3. Okay, that's easy. That's easy. The third question, if you missed that one, I don't know what to say. You need to come in and get some help. That's 2 points, 2 ordered pairs. You need to find the slope, and then you need to write the equation of the line, right? You need to go to the nurse.
Right now.
Yeah. Go to the nurse. Get that taken care of. So, let the nurse know we got somebody coming. I'll talk individual things like that. I'll take it after class, okay? Okay, here we go. And then the very last problem had to do with your power functions. Okay, so we've been through this now a few times. Power functions have shapes like this, only quadrant 1 now. We're confining the conversation to quadrant 1. Power functions look like this, they look like this, or they look like this, right? And all totally depends on the size of the power. So the shape that you have on the paper there is this one, right? So what size power does that shape correspond with? Not less than 0. This one is less than 0. This has a power less than 0. What's this one? Between 0 and 1. Your power is between 0 and 1. So when you look at the options you have, one of the powers is 2/5 and the other one is -2. So the answer must be x to the 2/5. If the answer were the negative power, it would be this curve right here. This would be the shape that you had, because this is the one that goes with negative powers. All right, so let's tuck those away. Keep those for future reference. And now I'm going to section 2.2. This is a homework question someone had. Section 2.2, problem number 51. So I'm going to 2.2, problem number 51. Okay, so here I am. This is section 2.2, problem 51, which is a homework problem that some people who have been working on homework have an issue with. The volume of an enclosed gas varies inversely as pressure. I'm going to stop right there. Volume varies inversely as pressure.
Wait, what's the problem number?
51. 2.251. Now, remember there are two kinds of variation that there's more than that, but two that we're concerned with. Direct variation, in which your equation or your general format is this, and then inverse variation, in which your general format is this. So the problem very clearly states inverse variation, and we have volume and pressure as our variables. Now it says the pressure of a 3.46 liter sample is 0.926. Okay, so it says the pressure of a 3.46. What's the 3.46?
Volume.
That's fine, that's liters, that's volume. So 3.46 equals K over, what is the pressure? 0.926. So that is going to allow me to solve for K. Would you agree? Now, they gave me a temperature, right? Does that have anything to do with my equation? No, because my equation is relating volume and pressure. So I just have an extra piece of information, which is great, but I don't need it. So I got 3.20396 if I pressed all the buttons right. All right, now that's my K value. Okay, so now it says, what would the, go back, here's my equation. What would the volume be at a pressure, excuse me, of 1.452? Now, how am I going to figure that out? I'm going to put in the K that I had, right? I figured out K. So now I'm just going to take that number I just got and divide it by 1.452. And the volume is about 2.21. Oh, that would be liters. Because it would match whatever the first volume was. Okay, so my guess is that whatever other problems I've assigned in that set, they're going to be like two-step problems, where what's the first step? Figuring out what K is, and then the second step is actually going on and answering the question. Okay? All right. Now, let's get out our packets. We have a few more little odds and ends things to learn, but let's kind of recap as we think about a quiz tomorrow. Let's kind of recap, you know, some of the stuff we've done so far. So on the very front page of your packet, we already did the tennis court problem, but we haven't done the other four. So let's do the other four now. So we're on the very front of your packet. We've already done the tennis court problem, number 5, but we're going to do all the rest of them now. Okay, so here we go with number 1. It says evaluate the function. Well, you know how to do this. What do I do? F of x is this. What do I do? You plug it in. Somebody said you just plug it in, and that's exactly right. So what do we plug in? We plug in 2x, and we plug it in for every x. So 3 times 2x squared minus 4 times 2x plus 5. It's just a matter of plugging it in. Now, what happens first here when I go to simplify this? What am I going to do first? Square, PEMDAS, exponents, right? So we're going to multiply or square this first. So that's going to be 3 times 4x squared. So that first term is 12x squared. And then minus 8x plus 5. And you're done. That's it. Don't do anything like try to factor it or quadratic formula or anything like that. No. Your job was to figure out what happens when I plug 2x into that function. This is what happens. All right, now a little bit of caution. If you've been asked to find this, well, we're going to plug it in, right? But when we plug it in, now we're going to plug it back in the original, so it would be 3x plus 1 squared minus 4x plus 1 plus 5. Now when you simplify, what are you going to do here? Foil. You're going to FOIL it out. And then distribute and collect like terms, and you'd be all set. That's not too bad. All right, number 2, sketch. Oh, we can do this. We've done lots of this. There's lots to remember, but we remember it all, hopefully. So what do you start with? When you look at this big problem, what do you start with? You put your x-intercepts on, your zeros on. And since it's already factored for you, you just plot those points, and there they are. Everybody okay with that? Now, you do want to pay attention to these, right? That goes with this one. I'll put a little X here just to remind myself. And that goes with this one. Now, what's special about those 2 points? Sam?
They don't go through, they just bounce off.
They bounce off. They don't go through, they just bounce off. Okay. What is the degree of the polynomial? 5. Okay, so that's odd. What does odd mean? Starts down, ends up. So the curve starts down here. But you told me when it hit this point, because of that squared, I'm going to bounce off of it. Right? And then I'm going to turn around and I'm going to come back up. But uh-oh, that one, going to get bounced off of that one too. And I got to turn around and come back up. And it goes right through that one, and there we are, starting down and ending up. Is that okay with everybody? All right. Number 3, find all the zeros. What's another word for zeros? What do you mean by zeros? X-intercepts. And where do the x-intercepts come from? The factors. So basically, we need to factor this thing. We want to find the zeros, we need to factor it. Now, take a close look at that one. Do you see anything special about it? It groups. Kids, if it groups, do that. Oh my goodness. That's always quicker and easier than all that guessing stuff is. So, let's give grouping a shot. So here we go. Those 2 I can take out x squared. These 2 I can take out a -4, leaving me with x plus 5 because I'm pulling out the negative. When that happens, all is well, right? So I've got my x plus 5 and then my x squared minus 4. And what about x squared minus 4?
Difference of squares.
The difference of squares. So at this point, you could graph this thing, but it doesn't say graph, it says tell me where the x-intercepts are. So where are they?
-5, -2, and 2.
That's it. That's it. Easy. So if you had to graph it, you would start with those points just like we did this one. Now, notice number 4 has the exact same directions. Find the zeros. What's different about number 4? Well, we're finding the zeros, so we could set it equal to 0.
We can't group these.
But it doesn't group. That one doesn't group. Okay, so what do we do if it doesn't group? We start guessing, right? So if we want to narrow down our guesses, our possible rational roots would be factors of 6. So factors of 6 plus or minus 1, 2, 3, and 6 over factors of 1. So these are the numbers you're going to guess. And your objective is when you guess them, you want them to equal 0. When it says find the zeros, it means find the numbers that you plug in to get 0. So I don't know, does 1 work? I always start with 1. No, 1 does not work. Does -1 work? And again, this is I'm standing up here at the board doing the problem, so I get to pick. You get to pick at your seats. So if you don't want to try 1 and -1, I don't care. Pick something out of this list and see if it works. So -1 plus 2 plus 5. I think I found one. -1 works. So the direction said find the zeros. One of the zeros is -1. What do I do now? I divide it out. So here's my -1. There are my coefficients. There's my remainder of 0, which I knew I had to get when I did my division. Now what?
You put it into x squared plus 2x minus 6.
I'm going to write this guy as a polynomial. So since I divided x cubed by an x, I'm going to have x squared plus x minus 6. Very good. And that luckily factors. They don't always factor, and if they don't, we can use our quadratic formula. But this one does factor into x plus 3 minus 2. Now the question said, what are the zeros? So I have to say, okay, the zeros are the -1 that I guessed, and then the 2 I get here are -3 and 2. Is that okay with everybody? All right, let's turn it over. And on the back, did we already do 5 and 6 on that?
Yeah.
Okay, so we're done with those. You might want to look those back over again. We did those another day. Now there are a couple of different problems on here. A couple of things that we really have the foundation for, but we haven't talked about too much. So one is problem number 1. It says find the remainder of this division. Now, could I do if I have to find the remainder, could I literally divide and find the remainder? Why am I a little hesitant about that with problem number 1 on this quiz? The exponent is 50. And you're thinking, what does that mean? Well, what does that mean? That means if I write out my synthetic division, I'm going to have about a zillion zeros in here, right? This problem could be huge if I chose to do it by division. So I want you to think about something that we have already been practicing, but I haven't really articulated. I want to come back to this problem that we just did. And I said, I'm going to see if 1 gives me 0. And I plugged it in, and 1 did not give me 0. What did 1 give me? What is that, -8? Okay, and the fact it's -8 isn't really important to me. I needed it to be 0, and it's not. But what if, instead of plugging in the -1, or the +1, what if I would have divided by 1? Now, some of you do this already, and that's perfectly okay. If I divide, oh my gosh, the remainder is the same number I get when I plug the number in. Now, when I plugged this one in, I got 0. What was my remainder? 0. When I plugged this one in, I got -8. What was my remainder? -8. So if all you're interested in is the remainder, you can get it 2 ways. You can do the division, or you can just plug the number in. You're going to get the same answer either way, if all you want's the remainder. So, thinking about it like that, I have this big polynomial that I want to divide by x plus 1. We have decided that actual division would be inconvenient because of all the zeros. So instead of dividing, I'm going to plug -1 into this problem. If I did the division, wouldn't -1 be in the box out here? Whatever number is in the box is the number you're going to plug in. All right, so negative 1 to the 50th times 3, what's that going to equal? It'd be 3. If you raise a negative to an even power, isn't it positive?
Yeah.
That's just going to be 3. All right, what's going to happen here? It'd be plus 8, because negative 1 cubed is negative times negative. What's this one going to be? Plus 9, and of course minus 2. So what is that? 18. The answer to the question is 18. If you want to know what the remainder is, you just plug the number in. Kids, that's why I do this, because I am searching for something that gives me 0, because that means the remainder is 0, which means I have a factor. Okay? All right. Number 2. Oh, we can do number 2. We just did a couple of them. Try number 2 on your own paper then and see how far you can get with it. We just did 2 problems exactly like it. We're finding the zeros. So your first thought is what?
PRR.
Well, your first thought, I hope, isn't PRR, because that sometimes is gonna cause you more work. Your first thought should be, does this group? I don't want you spending 15 minutes trying to figure it out. Just kind of scope it out. I see a 15 and a 17. What are my chances of grouping? Like 0. So I know this isn't gonna group. So now I'm thinking PRRs. So there aren't very many of them. What are my PRRs? 1, 3, 5, and 15 over 1. That's possible rational roots. These are my only possible answers right here, rational answers. All right, so see if you can find one. 1? 1 works? All right, that's good news. So let's divide it out. For those of you that are still off there in La La Land, when we say it works, we mean it leaves a remainder of 0. It's a factor. Olivia?
If we plug it in and it gets 0, isn't like the whole synthetic division thing not really necessary since we already know that the remainder's going to be the same?
Okay, the only problem with that is there are still 2 more you have to find. So if you do the division, you have it down to a squared, a quadratic, which then you can factor and you don't have to do any more guessing.
Yeah.
Does that make sense? Yeah. So yes, in terms of knowing that's a root, no, it's not necessary. But in terms of finding the other ones, this really helps. So one of our answers is 1. You guessed that. We divided it out. Now we've got this. Patty?
I already factored it.
We already factored it as
X plus 5 and X minus 3.
good, which means the other 2 roots are,
Negative 5 and positive 3.
here we go. Everybody okay with that? Now number 3. Oh my, this is backwards of what we just did. What we just did is you had the polynomial and you found the roots. Now what are we doing in number 3? You have the roots and you're going to build the polynomial. Now that's an easy process. Sometimes it can be tedious, but it's an easy process. However, there's one piece of information I need to give you. And that is this. And this should make sense to you. That's a complex root. That's an imaginary root. Think about the problem we just did. The only way that would have happened in this problem, let's say, the only way I would have gotten an answer like that is if this hadn't factored use my quadratic formula, right? That's how I get i's. Now, every time you use the quadratic formula, you've got this guy going on, right? So think about the answers that you've gotten every time you've done a quadratic formula problem in your life that's been imaginary. Haven't you gotten answers like 2 plus or minus 3i over 7? Or 2 plus or minus I root 7 over 6? Things like that. In other words, you never got one imaginary answer. It never came out just 2 plus 3i. So imaginary roots never appear without their conjugate. Now, they're not going to tell you that, and I'm not going to tell you that. I'm going to say one of the roots is 3i, and you're going to have to automatically know that another root will be negative 3i. Okay? This one, if you think about it longhand, is 0 plus 3i, so this one is 0 minus 3i. That's how I did that. It's the conjugate. So if this had been 2 plus 3i, this one would be 2 minus 3i. They always come together. You'll never have just one complex root. Okay? So now I've got 3 roots. Now, again, I'm glad we have this one up here. Come back here. If I gave you these regular numbers, no i's, these regular numbers, and said, build the polynomial. You have to go home.
No, she doesn't know it yet. But she doesn't want me to.
She's afraid it might be contagious, isn't she?
Maybe.
Yeah. Pink eye is hugely contagious.
Oh,
Okay. Well, take care of yourself, Lana.
right. Oh,
Okay.
here she comes.
I just thought that.
I thought it was for context.
Well, it could be Pico.
Or she can get that from her mother.
Oh, you can? I didn't even know.
The last thing in the world you need is
Oh, it's rats. I can't get pink eye. My grades are in a situation where I can miss
I
like
still
that.
have
I just want like this.
some
Walk the back of your
compromised
toes, you
immunity,
know.
so we'll do that. Thank you, girls. Okay.
To her goodness gracious.
Here's how you understand. Where did these numbers
Oh, our class is full again.
Where did these numbers come from? These numbers came from these factors, right? So when you build your polynomial, you have to work backwards to the factors. So x minus 1, x minus 3i, x plus 3i. There are your factors. Now, on a few of the problems in the homework, I have said don't multiply out. You may not have understood what that meant when you looked at it, but don't multiply out, or on the review sheets it says don't multiply out. This one I would want you to multiply out. This one is multipliable. If you get a whole bunch of big factors, I don't want you wasting your time foiling it, but this one we can do. I always suggest multiply the conjugates first, because a bunch of stuff will cancel out. So I'm going to do this foiling, and notice what happens, exactly what I just said, right? Oh, be careful here. Last times last is minus 9i squared, but that's plus 9, so x squared plus 9. This guy, this stuff right here, just came out to be x squared plus 9. You okay with that? And I still have to multiply that by x minus 1. I'm not done. I still have this factor right here to go. So I have x cubed minus x squared plus 9x minus 9. And there is my polynomial. All right? Now, let's try one more of those, just to make sure everybody's on board. Okay, so I'm going to do another one. We're going to come back and do that last problem in just a second, but I want to do one more of these. Let's suppose your job is to write the equation whose roots are x equals 2, x equals 4 minus I. Okay, so here we go. We're doing the same thing we just did. We're building the equation from the answers. This is not on the quiz. This is an extra problem I'm doing for extra practice. Okay? Now, first thing you notice is, okay, I have a complex root, which means if 4 minus I is given, 4 plus I is also given. Now, working backwards now, you have to build the factors. Kids always want to just multiply those together. You can't do that. You have to multiply the factors together. So a factor of 2, or excuse me, a root of 2 means you had a factor of x minus 2. Now look, x minus 2, right? You brought it over, so it was on the same side, x minus 2. So this factor, I'm going to bring these over, so x minus 4 plus I, and bring these over, x minus 4 minus I. When you write the factor, the number comes over with the x. So everything gets moved over with the x. Now, you're not going to like it, but we're going to multiply those together first. Because the same thing will happen that happened over here. You're going to lose a bunch of stuff. Do you remember how to multiply when you have more than 2 things? You kind of do the same thing, you just can't say boil, really. You take, personally, I take this guy right here times all 3 of those. So that would give me x squared minus 4x minus ix. All right, and then I go to this guy, negative 4, and I take him times all 3. So minus 4x plus 16 plus 4i. And then I go to this guy, I, times all of those. So that's xi minus 4i minus I squared. Now, order isn't important, but you gotta end up with 9 things, because each of these has to be times by each of those. Now, what do you notice when you look at that? The IX's cancel, right? The 4 I's cancel. And what about negative I squared? Plus 1, which will add to the 16 and give me 17. These 2 add together and give me negative 8x, and then I've got my x squared. So that mess just came out to be this. And now I need to multiply that times my x minus 2. Don't forget, we haven't done that one yet. So here we go. Again, I'll take this times all of them. So I have x cubed, 8x squared, 17x, minus 2x squared, plus 16x, minus 34. I hope I did that right. Collecting like terms, I have an x cubed, minus 10x squared, plus 33x, and minus 34. You okay with that? Now the happy news is problem number 4 is exactly the same concept, because what do you know about negative 2, positive 1, and positive 3?
They're all zeros.
They're the zeros, aren't they? These numbers right here? Now the only thing you have to pay attention to is that graph behavior. You know right now that your factors are x plus 2, x minus 1, x minus 3. You know that. Straight from the graph, right? Okay, what you have to pay attention to though is it bounces off at 3, which means what about your equation? That one is squared. Now there's something else going on here. It's upside down. Now I have no way of knowing what this number is, but I know whatever it is, it's negative. It's negative because the curve starts down, ends down, and that only happens with a negative coefficient. Now, the quiz you just took, you were given some information about a graph, the vertex at another point, and you wrote the equation, right? What allowed you to find this number out here? What information did I give you? Not just the vertex, but I gave you an extra point. So had you been given an extra point on this graph, not one of the zeros, but some other point on the graph, you would have plugged it in for y and x, and you could have actually figured out that number.
The same number for every x.
You put it in for every x, yep. And then, so if x was 1, you would put 1s in for every x. And if y was 2, you put 2 in there, and then you can figure out what that is. But I didn't give you that extra point. So this is as far as we can go. We don't know what that number is. Does that make sense to everybody? Okay, all right. Let's do one more thing. The very next page is just a little 3-problem quiz. Oh, actually it's not. It's got a back too. So let's do the front and back of this. And would you do it with your partner? We have a few minutes here. So do it with your partner. Let's see if we can get the front and the back of this quiz done.
My partner. You know what you're doing now? I know you don't.
I don't know.
I did not draw that. But I am going to just want to relax the work.
Probably because I was so used to never having things. I know all the things. I think we could back it up. I think we could do that.
Think so?
Yeah.
It's either 1,
Square,
-1, 2, -2,
And then
take out
the negative 4. Well, another x plus 4, so we know negative 4.
This is a difference of squares right here.
X squared plus 2x.
Yep.
That's easy.
And then we just.
And then we just find all the zeros.
This isn't right. I totally took that like a while ago.
Yes.
But so we're just gonna pretend like it's not here. But like
Ignore the
Alright, so
let's sum all the zeros. -2. You just put it in first.
3. And then that.
It took me a second too. I was like,
So I don't use that.
And it's even. Starting up and
We don't. This is. Oh no, this is. Okay. Boom. Get that Mallory.
nice.
Do you understand it though? Or do you want me to read it?
Finally, let's work on number 3.
Okay, well we gotta let Mallory read it.
You can
Are you a part
you
of
can put
the
your
show?
check on the board if you want.
squared, so it's 2, 3.
How do you know it goes positive for here?
Because it's 3 different degrees, right? 3 different points. So
Four.
that's,
It's 4 degrees, but you graph x, but 3 gets 0.
so since it's 4 degrees, because the x minus 3 squared, it counts as 2. So since it's like 4 of them, that means it's going to be even. So it starts up and ends
The
up.
one's not squared.
Alright, so f of x minus 2 and f
So
of
that's
yeah.
Wait, why did it go into this one? Because it's not squared. Yeah, it's squared.
But it's going to be t.
The right, that's the I was doing it in like
X
order,
squared.
yeah. Yeah.
squared.
Alright, I'll take care of this.
Times 2.
And then we just simplify.
Are we doing just the front with our partners?
With the
Yeah, we're doing the front and back. So if after you finish the front, kind of look up here and check your answers with mine. Now, one thing I want to comment on, the directions to number 2 said label all intercepts. Okay? Now, I have no doubt you got these guys labeled, right? The zeros from the factors. But there are not only x-intercepts in a graph, there is also a y-intercept. And how do we find a y-intercept? What do we know about y-intercepts? The x-coordinate is 0. So you have to plug, if you want the y-intercept, you have to plug 0 in for your x's and calculate what that is. The y-intercept is the value of y when x is 0. Look, isn't it 0 comma something? So you're going to let x be 0 and plug it in. So pay attention to those directions. So before you go to the back side, kind of check your answers here for the front side, because I'm going to run out of room and have to erase. Maura?
Okay, so when do you just graph the intercepts that it gives you? Like when, like, since it said label all intercepts, when do you just graph the ones that, like, the x-intercept?
No, all intercepts means any point that intersects an axis.
No.
So these are the x-intercepts, but you also have a y-intercept.
But I mean, like, if it's like, when do you not, like, do you ever not graph the y-intercept?
I would not have graphed it had I not been told to plot all the intercepts.
Okay, so.
Yeah, yeah. It says specifically to do that, so we're gonna do that. Okay, so I've started forming, I'm not done with it yet. Any other issues? Did everybody notice one grouped? And even if you didn't notice, did you end up with these roots by guessing and dividing? Graph okay? I need some more room, so I'm going to erase these now. Is that okay with everybody? Everybody good with these?
Yes, sir.
It's okay. There we go.
Yes, sir.
Because this one's going to take me a little space.
just thought probably not one. It doesn't really make sense. I knew it had to be kind of so I was gonna guess five. This one says if one satisfactory doesn't.
Can I erase number 3? Did everybody FOIL and get the correct answer to number 3?
Yes.
Everybody okay? All right. You stand warned. Anybody now in pre-calculus that doesn't do this correctly, that says something like x squared plus 4 or something weird like that, you're losing half credit. No more of these 8s for that. That kind of mistake's gotta stop. Make sure if you have a binomial and you're squaring it, that you FOIL it out. Okay? So everybody good with this? Because I'm gonna erase it. Alright. So I have 4 done. It's kind of spread out all over the place here. 4 is done. Hopefully you're working on it.
What? Hey, did you start number 5? It was my arm.
Ah, hurts.
We don't have an actual clover.
Come on, Peyton.
Yeah, they said it on some like.
Wait, on some of this stuff.
Yes, number 4.
It's been on some stuff. It's been on some of the legal stuff.
Yeah,
Nobody does a 4-leaf clover like.
Because it's the
Is that
same,
like
our
my
stuff is the same color.
yeah, that's the answer.
4-leaf clover's like lucky.
Okay, I have the answers to 4 and 5 boxed in up here. The book is kind of scattered all around. All right, number 4, how are you doing on that one? We've done several of those today. It seems like we have anyway. Maybe it's only been a couple, but it doesn't group. So did you start guessing? And I heard some great conversation over here. Just kind of overheard it. My favorite numbers to try are 1 and -1. But when I have situations like a -30 hanging on the end, 1 isn't going to work. Does that make sense to you? I mean, people were talking about not even trying it. Sure, you can try it. Go ahead. But it's not going to work because you can't throw that -30 in there and have it end up being 0 if you're only putting in 1. So I started with 2, and 2 didn't work. So I went to -2, and it did. You may have started with something else. So I divided it out. What I had left factored. So I ended up with these roots right here. How does that seem to everybody? Is that
We got like we did 3 and we got the same answer.
Well, of course you did, because 3 is
Oh,
an answer. So she said, did you hear that? She said, we guessed 3. Awesome. Would 3 have divided in and given her 0?
yeah.
So then her quadratic that was left factored into x plus 2, x plus 5. And you got the other 2 roots. Yeah, the order you achieve the roots doesn't matter. The roots are the roots. There's only one answer to this question. The order we get them doesn't matter. okay? And then we got our little word problem. We've done one like this before. We're building a fence, but we're using fencing on 3 sides. So I let these 2 sides be x, and that meant this side was 120 minus 2x. Why? Because I only had 120 meters of fencing. So if I cut x of it off here and x of it off here, that left me with 120 minus 2x. The problem says find the area, maximize the area. So length times width. If I want to maximize a negative quadratic, that means find the vertex. I did negative b over 2a and got 30. So x is 30. 120 minus 2x then was 60. So my maximum area is 1,800 square meters. Does that sound okay to everybody? All right. We've done what, 2 practice quizzes today? 3 practice quizzes today, parts of 3 of them. So you have a sense of what you need to know, right? Does anybody have a question about this last quiz? Everything's good. All right, I'm going to give you one more, the final piece of information for this unit. It will not be on the quiz tomorrow. This particular item will not be on the quiz tomorrow because we don't have much time to practice it. But I want to be done with you guys. I want to finish up with you guys. So here we go. Here we go. If you have a polynomial function, let's say 2x to the 6th minus 3x to the 5th, 4x to the 4th, 9x cubed, 8x squared, 7x plus 3. Okay, there it is. Now, right now, panic is filling your heart because you're thinking, oh my gosh, this is going to take me forever. No, we're not going to find the zeros. Okay, we're not going to find the zeros. What we're going to do is find the PRRs that you already know how to do, the possible rational roots, and what would they be in this problem? Factors of 3 over factors of 2. So that would be not just 1 and 3, but it would also be 1/2 and 3/2. Does that make sense to everybody? Okay, so those are the possible rational roots. We also have a technique for determining the nature of the solutions. Now what that means is, are they real? Are they imaginary? Are they positive? Are they negative? How many of them are there? Well, we know total there are how many? 6. But how many of them are real? How many of them are imaginary? There's a technique for determining that. It is called DesCartes Rule of Signs. And you will use DesCartes' rule of signs. This is the same Rene Descartes, the Cartesian coordinate plane. You'll use DesCartes' rule of signs anytime you are asked for the nature of the solutions of a polynomial function. The breakdown for Descartes is this. It will tell you how many, the number of positive real roots, the number of negative real roots, and the number of imaginary roots. So using Descartes' rule of signs, you will have a sense of how many positive roots there are, how many negative roots there are. Could that be a helpful piece of information when you were guessing? Yeah. All right, so here we go. How does it work? Well, I think you may have done this before. Look at your problem and simply go from term to term and count the number of times the sign changes. So this would be positive, negative, positive, positive, negative, negative, positive. So how many times does it change? It changes here, it changes here, it doesn't change here. See how I went from positive to positive? Oh, it changes here, it doesn't change here, but it changes here. So do you understand what I'm talking about when I say the sign changes? I'm going from positive to negative to positive. Okay, so how many is that? 1, 2, 3, 4. So I put a 4 here. To get the number of positive real roots, I simply count the number of times the sign changes. Now, here comes the tricky part. It has to do with the fact, we talked about earlier, complex roots come with their conjugate pairs. But if it's 4, it could also be 2, or it could be none. When you count your sign changes, and we got 4, whatever number you get, you reduce it by 2's until you can't reduce anymore. So if there had been 5 sign changes, I would say 5, or 3, or 1. You reduce it by 2 till you can't do it anymore. DesCartes was a really smart guy to figure this out. Now, negatives, you do exactly the same procedure, except pretend x is a negative number. Pretend x is a negative number. Well, this term would still be positive, right? But what about this term? Oh, if x is negative, well, won't this become positive? What about this one? Still positive. What about this one? Negative, negative. This one would become positive, and that one is, of course, positive. We're letting x be a negative number. How many times does the sign change now in the problem? 2. So for negative reals, which we got by plugging in a negative number, by letting x be a negative number, there were 2 sign changes. 1 here and 1 here. But just like before, we count down by 2's. So this will be 2 or 0. Now for imaginaries, you're going to use your common sense. How many roots total did you tell me there were? 6. If 4 of them, these are possibilities. So if 4 of them are positive and 2 are negative, how many would that leave you for imaginary? If there's 6 altogether, Patty, and I got 4 and 2, that's going to be 0, right? Well, what happens if there's 2 and 2? Then there would be 2. What happens if there's none or 2? There'd be 4. All right, what happens if there's 4 or 0? Or 4 and 0? 2. How about 2 and 0? 4. How about 0 and 0? 6. So the number of imaginary roots could be 0, 2, 4, or 6. 2 quick comments. I know we've done a lot today, although most of those review. This is not in the quiz. We'll do some more of this next time. But I want to make 2 quick comments about it. See this row of numbers right here? They have to be even. Why do these numbers have to be even? Because imaginary roots come in pairs. 3i comes with negative 3i. Secondly, this may or may not be helpful to you. When it is helpful is, let's say I was doing this problem, and I was guessing numbers to give me 0, and I found one. Let's say I plugged in negative 1, and it worked. What would I absolutely know then? If negative 1 actually worked, what would I be guaranteed? there's another negative number that will work. Because this says the number of negative real roots, there are either 2 or none. So if you have found one, then you know there has to be another one, right? So that's a tool. You don't necessarily have to do it in every problem.
Is this coming up a quiz tomorrow?
Could be. It's the same stuff we already did, isn't it?
Okay.
Yeah. They're the same problems that we've already done. I mean, different problems at the same time. Okay, you guys are done. Great job. Good work. A couple of you had issues with your quiz. Bring them up and I'll take a look at it. I don't know. Is it flex now?